Team, let's kind of look at some of these mixed problems. This is essentially us trying to, instead of just looking at problems as specific type, I'm going to try to mash the bowl of potatoes together. Let's go ahead and dive in and see how well do we fare in Unit 1. All right, so these first two are essentially, can you write a quadratic formula? The idea is that based on the information, you go ahead and select the right equation. The words that shot out to me are concave up, stretched vertically, and it has the x-intercepts of -3 and 4. Immediately seeing this word x-intercepts tells me that my answer is going to be in factored form. It is going to be f of x is equal to a concave up because it needs to be positive. It is stretched vertically. It is getting bigger. When you stretch something, it gets larger. I'm going to double it. And then now I'm going to remember that the factored form is always going to resemble x minus blank, x minus blank. And these blanks are the solutions, -3 and 4. I take a moment to clean up my final answer, and I get 2 times x plus 3 times x minus 4. Okay, this next one. Write the function below in standard form. It is currently in factored form. Factored form is very good to identify the zeros as we've seen above. And this is where in the past we've gone 0 is equal to 2x minus 3, and then x plus 5. And then you would go from there and you would have your two equations, 2x minus 3 equals 0, x plus 5 equals 0. And then you would solve both of those to get the x-intercepts. That's not what we're doing here, though. We need to just simply transform it from factored form to standard form, which means we're going to have to multiply. We're going to have to multiply 2x minus 3 and multiply by x plus 5. So I'm going to go ahead and go at it, figure out some products using my area model. And I'm going to go ahead and end up getting g of x, writing it in descending order is 2x squared plus 7x because 10 minus 3 is 7 minus 15. This form is awesome because the concavity is going to be positive, concave up, which means it's going to have a vertex that is a minimum. Also, the y-intercept is always going to be the c value. So I know immediately it's 0, -15. If you're confused about where to put the 0, vision a graph to the side, put a point on the top, and put a point on the bottom. They're y-intercepts. Notice how the green point would have to be 0 to the left and up a number. This value would be 0, -2. And notice how the y-intercept always has an x that is 0. Okay, continuing this journey, determine each key feature of h of x. Notice how it is in vertex form. Immediately, I rewrite it to build the skill of visualizing the vertex. I'm going to represent it, this plus, as a double negative in order to accurately determine the vertex. Without doing it this way, some of you might be tempted to write 4, 2. That is not the case. The vertex is -4, 2. Okay, axis of symmetry. Let's go ahead and to build this picture, it is concave up or concave down. And since it is negative, it is going to be concave down. The axis of symmetry is where the vertex cuts it in half. It is always going to be the x value of the vertex, which is going to be -4. X equals -4. Finally, is it going to be a max or min? I look at my concavity. It is at the top. It is going to be a maximum. All right. Continuing to flex, we need to figure out what could model the graph. So in order to do this, I'm going to ignore these equations for right now, and I'm going to just look at this graph. The key features in my brain immediately I see are these x-intercepts. I notice that both of my x-intercepts are positive. So let me write that down. X-intercept, positive. I know that my vertex is right here. And the coordinates of this vertex are both going to be positive as well. I would have to go a positive number to the right and then rise a positive value. I also see that it is clearly concave down, so A is going to have to be a negative number. Let's go and see if I can eliminate any. Starting with concavity, I look at my leading terms, and I need it to be concave down. So this guy is eliminated because g of x is a function that is concave up instead of down. Now let's continue our journey. I'm going to go ahead and start with f of x. It's in vertex form. Let me ask myself, what is this vertex? Looking at it, I should be able to pull. It is at 4, 8. If I went and graphed this on the graph, 4 to the right, 8 up there, this is a possibility. So the reasoning I can use is it is both concave down and the vertex is in quadrant 1. If you want to recall the quadrants, it goes counterclockwise. 1, 2, 3, 4. Let's look at h of x. Immediately, my brain wants to see that what makes the zeros? Well, what number makes 0? X minus 5? 5 and 3. So these are going to both be x-intercepts, 5, 0, 3, 0. Notice how they're both positive. So this works. It is both concave down and the x-intercepts are positive. Let's look at this last guy, k of x. I immediately solve, and I see that these factored form is going to both be -3 and -7, essentially meaning that this graph would be concave down and it would go through -3 and -7. You can see how it's on the opposite side. So it is disqualified because the vertex or the x-intercepts are not on the right side. The x-intercepts are negative instead of positive. Okay, for number 8, the last thing to do is see if these are equivalent. Use your skills, put them together, combine like terms. Y is 3y plus 2 plus 3y, which is 6y plus 2. It's matched. They are equivalent. What did I do? Because I combined like terms. All right. I know I didn't go over every problem. That's on purpose. Help use this to model and go ahead and complete 2, 4, 6, and 9 on your own. Hope this helps. Good job.